this part, I'm going to elaborate wave nature and the particle nature of light, and we are going to discuss two famous theories of light, quantum theory of light and wave nature of light as given by De Fresnes. So in this scenario, we are having two main effects that explains the particle nature of light. The first one is actually photoelectric effect, and another phenomena that complements the particle nature of light is Compton effect. These two effects are these two phenomena are just given in your book. They haven't explained it, so let's have a look in detail. What happens in photoelectric effect is that when light or photon of energy having some energy value electron volt is incident on some solid material having having loosely bonded electrons and their nuclei. This pool of loosely bonded electrons, they absorb energy from the photon or the incident light, and they absorb the energy and they break off their atomic binding. They utilize this energy to break the atomic binding between them and the nucleus, and they get themselves free. So these free electrons, now they are, since in motion, they have certain kinetic energy. So what happens is they have absorbed the photon of energy from the light rays incident on them, and they get free. So this effect is actually supporting particle nature, that light as a particle or photon in nature is absorbed by the free electrons of charged particles, and then the electrons are released, and these electrons then can be used in different processes or in semiconductors. Usually we use such fact in electronics to derive electronic current. Now this photoelectric effect is further validating the particle nature of light through Compton effect. That is, photoelectric effect validates Compton effect, and Compton effect is actually validating particle nature of light. It says that whenever high energy photons are actually X-rays or maybe gamma rays, when they are incident on some material having loosely bonded electrons, shown like this, these are loosely bonded electrons, and these are the actually nuclei. So these free electrons absorb the energy and get themselves free. They gain the energy and they become in motion. They are released with some kinetic energy, electrons or charged particles. So the photons, which were previously high in energy, they lost some energy to the electron, to the loosely bonded electrons, and then they are scattered at some angle. And there was an incident angle and there's this angle. They scattered at some angle and with some low energy. So the energy previous and the energy after collision and before collision was totally different. So this scattering is actually the main point that says that scattering of the ray or the photons causes the shift in the wavelength, and this shift in the wavelength was because of the angle of scattering or the way they have scattered. So since they have scattered, this scattering is actually a particular particle nature based, and it is further strengthening the photoelectric effect, and so particle nature of light.